All right, so we're going to tackle this problem here um, that you gave me. You're talking about finding the arc length of the parabolic curve r equals 16 over 1 plus cosine of theta. So I don't know if I have a skeleton key, but let's take a look at this and see if we can figure this out together. Okay, so I took the liberty of kind of writing down get some of the prerequisite work out of the way. So recall that the formula for finding the arc length for polar curve is given by the formula integral of the square root of r squared plus dr over d theta squared d theta. And so in this case, our r function is 16 over 1 plus cosine of theta. So r prime, or dr d theta, would be positive 16 sine theta over 1 plus cosine theta quantity squared. So with that one, you can use the quotient rule or the product rule or the chain rule, whichever floats your boat, but that's what you get for the derivative there. Now, since we're going to be squaring the quantities on the next line here, we have just that. R squared equals 256 over 1 plus cosine squared. For r prime squared, or dr d theta squared, that's 256 times the sine squared theta over 1 plus cosine theta raised to the 4th power. Now, since the formula is going to require us to add these two quantities together, and they're both fractions, we'll need a common denominator. So I took the liberty of going ahead. In this case, the common denominator is going to be 1 plus cosine theta to the 4th power. So I multiply the top and the bottom of r squared by 1 plus cosine theta squared to get that denominator. All right, so now we're going to go ahead and put this into the integral formula. Now, since I can't hold the pencil and the phone at the same time, I'm going to go ahead and write that out, and then we'll explain those steps. All right, so continuing where we left off. So when we integrate, we put in the r squared, and r prime squared. So now that we have the same denominator, we can put them both over that denominator. So we have 256 times 1 plus cosine of theta quantity squared plus 256 sine squared theta. We expand 1 plus cosine theta squared, and that gives us 16 times the integral of 1 plus 2 cosine theta plus cosine squared theta plus sine squared theta over 1 plus cosine theta to the 4th power. Now, of course, we know that cosine squared theta plus sine squared theta is equal to 1. So putting that together, adding it to the 1 from the very first term, we get square root of 2 plus 2 cosine theta over 1 plus cosine theta to the 4th power. We can factor out the 2 from the terms up top here to get this result. Factor out the 2, we have 1 plus cosine theta over 1 plus cosine theta raised to the 4th power. We cancel out the common factor of 1 plus cosine theta. And so now, at this point, also taking out the 2, which will be the square root, we have 16 times the square root of 2 times the integral of 1 over the square root of 1 plus cosine theta raised to the 3rd power. Now, this problem is going to be a bit of a bear. We got to go back and do some trig identities and also recall some things from trig integrals. So we'll get into that in the next part. Okay, so now going back to our integral, 16 square root of 2 times the integral of 1 over the square root of 1 plus cosine theta quantity cubed. Note this expression, 1 plus cosine theta. This we need to do something with. So let's check this out. In our list of identities, there is a half angle identity that states that cosine of theta over 2 is equal to the square root of 1 plus cosine theta over 2. So we see that expression, 1 plus cosine theta. If we take this expression and solve it for 1 plus cosine of theta, we square both sides of the equation, and then we multiply by 2. We have 1 plus cosine of theta equals 2 times cosine squared theta over 2. So rewriting our integral, and this time I chose to rewrite the integrand in exponential form instead of radical form. So that's 1 plus cosine theta to the negative 3/2 power. I can replace the 1 plus cosine theta with 2 cosine squared theta over 2. So our integral is 16 square root of 2. 16 square root of 2 times the integral of 2 cosine squared theta over 2 to the negative 3/2 power. So raising the 2 to the negative 3/2 power, when we take cosine squared theta over 2 to the negative 3/2 power, the exponent 2 here will cancel out with the denominator of the exponent. So that gives us cosine theta over 2 to the negative 3rd power. Now, if we clean this up a little bit, 2 to the negative 3/2 power can be rewritten as 1 over 2 square root of 2. And since it's a constant, I'm going to put that in front of the integral. Also, since cosine is the reciprocal of the secant function, I can rewrite cosine of theta over 2 to the negative 3rd power as secant to the positive 3rd of theta over 2. So cleaning up the constants in front, we have this integral of 8 times the secant cubed of theta over 2 times d theta. All right, so now we've reduced this down to a power of a trig function. So to deal with this, we need to use the power formulas, or we need to use the integral formulas for powers of trig functions, in particular for the one for secant. So for secant cubed theta, if we use the integral formulas for powers of secant, secant cubed of theta is equal to 1/2 times the secant theta, tangent theta, plus 1/2 times the natural log of the absolute value of secant theta plus tangent theta plus c. So then going back to our integral, all we really have to do here is just replace the theta in the general formula with theta over 2. And so when we multiply that by 8, distributing everything through, this integral becomes 4 times the secant theta over 2, tangent theta over 2, plus 4 times the natural log of secant theta over 2 plus tangent theta over 2 plus c. And so now to do your arc length, of course, you'll be evaluating this over the limits of integration, depending on what they are. But we've evaluated the integral part, so we've evaluated the integral, so plugging in the limits of integration should be pretty easy from here. So I hope this helps. See you next time.